Hey guys, hope you're having a good snow day. Let's do a little trig right now and let's get started. If you have your calculator, why don't you grab your calculator and why don't you type in sine of 30 and get an answer. And then what we could do is we could check each quadrant and let's see what's going to happen with this. So I'm going to still use sine the whole way around. Sine 150, sine 210. Now remember, your calculator should be in degree mode. So punch it in and see what you get. And let's do one more, 330. So hopefully you're quick with the buttons. So what your calculator would say was 0.5, and I'm just going to write it as half. I know it's a half, negative a half, and negative a half. But now I understand that the angle's changing. So right, so like if we take a look, and 30, we're in the first quadrant. All right, so that's 30. The sign was positive. The sign was positive. And 150, say it's like this much. Let's call that 150. All right, and maybe I'll just put it up here so so it's easy to say. That sign was positive. And who else? 210 is in the third quadrant. All right, so 1, 2, 3, 4. And so at 210, that angle sine of 210 was negative. And in the fourth quadrant, 330, we also got a negative. Now, I could do this with the other functions, cosine, tangent. And like, for instance, if I typed in cosine 150, you're going to get a decimal, negative 0.866. But I'm just going to all I care about at this moment, it's negative. So the cosine here would be negative. And there's an easier way to do this than checking every single angle. It's a chart you're going to have to memorize. Okay, so make this chart, and it goes by quadrants. So 1, 3, 4. And what we want to do is we're going to use it's going to be, well, you can start with cast. So C, A, S, T. First quadrant is A, S, T, C. And it has to go in this order. Now, well, what does it mean? Well, the A stands for all are positive. All the trig functions you know, sine, cosine, and tangent, they're all positive in the first quadrant. S stands for sine positive. So sine positive. So what that means is cosine is negative, and I should put the thetas. Sine's positive, cosine negative. Tangent in this quadrant is also negative. Wild guess, T. Tan theta is positive. The other two are negative. Sine, cosine are negative. So instead of memorizing all these special things, see if a cosine's positive, what you memorize is ASTC. And some people say all students take class, all students take calculus. I don't care how you memorize it, just memorize it. Sine theta is negative, tan theta is negative. So at the moment, you really can't do much with this. But I can do the where am I game. Where am I game? Where am I? Okay, so the question is which quadrant? All right, and this is like a classic question, but this is an important piece of what we're going to be doing tomorrow in class. So which quadrant? All right, I'll start off. Ready? 1. The sine of theta is negative. That's not how you write that. Let's try it again. Sine theta is negative. Cosine theta is negative. Where am I? Look at the chart. Sine and cosine are both negative. You must be in quadrant 3. That's not how they usually ask it. They go like this. They'll use inequalities. They'll say this. Sine theta is greater than 0. Cosine theta is less than 0. Where am I? Now you got to realize greater than 0 means positive. Less than 0 is negative. So I'm really saying sine positive, cosine negative. So that puts us in positive, negative quadrant 2. Let's try it again. And sometimes they get tricky. They go like this. Sine theta greater than 0. All right, that's not tricky. We know how to do that part. But then they go like this. Tan theta is equal to 2.3. All right. And that throws people for a loop. But it shouldn't. Because what you're looking at is I don't care about the number. I care about positives and negatives. What kind of tangent? Well, it's positive 2.3. Sine greater, positive. Which quadrant is everybody's positive? You must be in quadrant 1. So that's the first part. Second part, special triangles. There's 2 triangles you must have memorized, special triangles. And once again, right today on this video, we're just going to do basics. It's going to be a much larger part that we're going to use from now until the end of trig. We use this the entire third quarter. We do trig, all 9 weeks. So here we go. 2 triangles. One is a 30, 60, 90. 30, 60, 90. And the other one is 45, 45, 90. All right, so here we go. 30, 60, 90. Now we just did this. The sine of 30 was 1/2, 0.5. So if I'm at 30 right here, the sine of 30 must be 1/2, 1 over hypotenuse, must be this. By using Pythagorean theorem, this side would come up as radical 3. And you don't write the decimal, you leave it as a radical 3. Because these are going to be problems that are going to say exact value, exact value. 45. Now, that means this is isosceles, the base angles are the same. These are both 1s, Pythagorean theorem. This is rad 2. They will always keep this proportion, the way the numbers are written. They always stay the same. So, when I do a problem, I'm going to go like this. Find the sine of 30, cosine 30, tan 30. So, let's start with this one. I'm down here at 30. Sine of 30, opposite over hypotenuse, 1/2. Cosine 30, adjacent over hypotenuse, rad 3 over 2. Tangent 30, opposite over adjacent, 1 over rad 3. But we've done radicals. You're not allowed to leave radicals downstairs. You must rationalize this. Up and down by rad 3. So this gives me rad 3 over 3. Try it again. Sine 60, cosine 60, tan 60. Opposite over hypotenuse, rad 3 over 2. Adjacent over hypotenuse, 1 over 2. Tangent, opposite over adjacent, rad 3 over 1, or just plain rad 3. That's all for the first triangle. Let's try the next triangle. Sine 45, cosine 45, tan 45. Doesn't matter which 45. I personally like to stand at the bottom. It doesn't matter. Sine 45, opposite over hypotenuse, 1 over rad 2. We're not allowed to leave radical downstairs. You rationalize rad 2 over rad 2. You get rad 2 over 2. These are exact values. That's what they're going to say. No decimals. Exact values. Cosine 45. Adjacent over hypotenuse. 1 over rad 2. We just did that. It's the same thing. So I'm just going to jump to rad 2 over 2. Same angle. It'll work out to be. Just works out to be with the isosceles triangle. Tangent 45. 1 over 1, or just plain 1. So what does this do? All right. At this moment, when we say something like find the tangent of 30, you should be able to make a triangle, label the correct triangle, and tell me flat out without a calculator what the tangent. These are special angles. So 30, 60, 45 are special angles. Also the unit circle, don't forget. Now, what else is true about this is these triangles hold the same proportion. So they keep proportions. So what does that mean? So real quick, if I have my basic triangle, right? 30, 60, 90. 1, 2, rad 3. And you're going to have to memorize this and be able to generate just that fast. If I have a bigger triangle, same angles, they're proportional. 30, 60, 90. And if I told you this side here was a 5, you should be able to label the other sides. All right, well, let's say if it's proportional, how do you turn a 1 to a 5? Well, we multiply by 5. So I multiply everything by 5. So 2 times 5 is 10. There's really a 1 out here. 1 and 1, that's the same. So therefore, the 5 goes in front, rad 3. Let's try it again. Let's do crazy, upside down, backwards. So 30, 90, 60. And I'm telling you that this was a 14. All right, we don't panic. We don't panic. All right, that's the hypotenuse is 14. That's the double. So that means the side opposite 30 should be the 1. So in this case, instead of 14, I put 7. Well, this is the 1 rad 3 side, so that becomes 7 rad 3. What if we do a different triangle, 45? Okay. Now remember, these are some isosceles. And if I put a 2 here, okay, so now we put a 2. Well, that means this was the same, so that has to be 2. And this was 1 rad 2, so that means this is 2 rad 2. Let's try it again. That's our last problem. I go like this. And I don't even put the angle in, but if it's isosceles right, it has to be 45, 45. And I tell you, this is a 6 rad 2. Right? We don't panic. So that means 1, 1, 1 rad 2, 6 rad 2. This has to be a 6 and a 6 because these were 45 degrees. And that's it. Don't forget, review your unit circle because you have to be able to generate that also. Make sure you know the unit circle, x is cosine and y is sine. That's the basic of it. And that's it. I hope you enjoy your snow day, and I'll see you tomorrow.